Hello, podcast listeners. You are now listening to the Coffee, Health, and Science podcast. I'm your host, Jordan River, and I want to thank you for tuning in today. Before we get started, please tell a friend about the Coffee, Health, and Science podcast. I appreciate you all spreading the show. We talk about natural farming on the show quite a bit, getting deep into the regenerative agriculture side, and I'm excited to kind of take a different angle on that subject today. We're going to be talking about aquatic inputs when it comes to natural farming. We're going to be talking about aquaponic farming, microbial life, and so much more with today's guest from Kingdom Aquaponics, Leighton Morrison. How's it going, Leighton?
Oh, it's going well, Jordan. A little crazy times, but, staying positive and keeping myself busy.
Nice. Good, my friend. Thank you for taking time to come on this show. We spoke off air. You are quite knowledgeable in the field of aquaponics. And honestly, I think aquaponics doesn't get enough play. It's a niche kind of area of agriculture, though I feel it's growing, and I'm very excited to talk to you. So thank you.
Oh, my pleasure. It's got a deep history, my friend. It goes back to the Incans and the Egyptians, who were actually basically rearing fish in ponds and then using that pond water to irrigate their crops. So this isn't new. Nowadays, it's usually done on land instead of in the ground. And usually in closed environments, but it's a technology or anti-technology that's been around for a real long time.
That's great. I love how you put that.
Yeah. And so why don't I start with a little bit about how I got involved in this? And
perfect.
It started when I was quite young, early teens. I was rearing, believe it or not, South African lake rift cichlids. So they're a brackish fish. The ones I was raising were frontoses, and I had a relationship with a pet shop where I would grow these fish and then sell them back to them. And I was getting $25 to $50 a piece for these guys.
Nice.
That was a lot of money back then.
Totally. Good little fish hustle there.
Yeah, it was a great little niche, and I loved it. I had 3 to 5 colonies going at any one time, and I'd love to just sit around and look at the fish and work with them. So it was a really nice gig, and part of my rearing was that I wanted to make it as natural as an environment as possible for the fish to feel comfortable and obviously breed quicker and be healthier. And so I would always have a tremendous amount of plants in each one of these colonies. Now, a colony would basically be 3 females and a male. And so I would give them adequate areas to build their nests. And then, after they build their nests, there'd be plants ripped up and moved around. So I'd take those plants and I'd throw them in a hospital tank to try to give them time to rest and rebuild themselves so that I could replant them again.
Interesting.
And so that was basically what I would consider a hospital tank. And I had this one male who was a great stud, but he was a bastard, man. He used to beat the hell out of the females. And so I got pissed at him one day, and I'm like, all right, you're going in quarantine, dude, or I called it solitary.
Solitary confinement.
I threw him in the friggin' hospital tank. I didn't feed him, didn't clean the filter. I didn't do anything. And all of a sudden, I started noticing that his fins were growing. His blue color was insane. He was super healthy. You could just see him tearing around the tank. And I'm just like, whoa, there is some real connection between these plants and that fish. And I don't know what it is.
Wow.
And yeah, so that was my first, experience. And that was before they ever coined the word aquaponics. But
the curiosity was sparked all the way back then, and it hasn't ceased.
Yeah. So then life went on. I got married, had kids, worked my tail off. And, I'm done with being a general contractor. I still like banging nails and being a carpenter, but there's no work. The marble and granite industry had completely collapsed because I'd been doing that for 15 years prior to 2008. And so there was no work. And so I'm like, well, what am I going to do with myself? And that's when I decided that I was going to do something that I was passionate about, something that I loved, something that was good for the environment, and was, made me feel good about myself.
Oh,
and that's where I said, all right, I'm going to get back into, I started looking around, and all of a sudden now there's a title for it. It's aquaponics. I'm like, I'm going to get into aquaponics because that was something that I really, really enjoyed. I didn't know whether I was going to grow fish for pet stores or fish for food or whatever. But that was where I was like, all right, this is what I'm doing.
Wow.
Basically, I started researching it and found this. It was called the second annual World Aquaponics Aquaculture Conference down in Cancun, Mexico.
Ha.
And I started looking at who the players were. There was Dr. Kevin Fitzsimmons, Dr. James Ricosi, and other heavy hitters in the industry. Now, Fitzsimmons did the display down at Disney, the Small World display, which is an aquaponic display.
Oh, right.
And James Ricosi had been doing what I did, except for he was growing the plants to sell to the fish store, not the fish.
Right.
And both of these guys started doing this, eons ago, 80s. There's another guy, Steve Van Gorder, that was doing it at Rodale. So I kind of call these guys the patriarchs of the industry.
Interesting.
And in my work, I wanted to see who had the best system, because I'm a wicked geek as far as engineering and building, because I did, general construction for 30 years. So there's no trade I can't do. And so I looked at Ricosi's system, which is called the UVI, University of Virgin Islands aquaponics system. And that one is by far superior in KISS and functionality, because in that system you have 4 tanks. So you always are rotating. The tank you harvest out, now you put small fish in it. And the other systems, it doesn't work that way. And the problem with those systems is you have nutrient difference. When you have very small fish and low biomass density in your growing tank, you're going to have low nutrients on the other side of that. So if you have half-grown plants and you harvest your fish and then put a bunch of little guys in there, the plants are going to suffer. And so, to get too far ahead of myself, but Ricosi's system has a rotation of 4 tanks. So you're constantly equally providing the same amount of nutrients per square foot of plant beds that you need. So again, it's a beautiful, simply system.
Interesting.
Now, if anybody wants to know about aquaponics, there is only one place that I would advise you to even listen to or look into, and that's called Santa Fe Community College. My good friend Charlie Schultz runs the entire aquaponics greenhouse technologies course there. He heads the department.
Oh, nice.
He worked under Ricosi at UVI for, 15 years or something. So you talk about having experience and understanding all the different systems and all the different nonsense that's being sold out there. He's your guy. And I'm willing to bet you there's online courses for this now, especially now that everybody's doing everything. Everything's pushing towards virtual at this point.
Oh yeah, that's a really good point.
I was just down there a few weeks ago with them, having some laughs and geeking out on aquatic biology. But and I know that the program has grown tremendously over the last few years, which is great because there is a lot of interest, and there should be.
Oh yeah, man. I'm certainly interested myself. Yeah.
So again, their online courses are not going to be ridiculously expensive, but I can guarantee you're going to get real information.
That's
solid
great,
information.
Man. Good recommendation.
So many of the systems that I see being sold are horrible. They don't have the right amount of aeration. You're not going to get the right amount of dissolved oxygen. You have no solid separation, and if you do have solid separation, it's such a nightmare to clean that it's cost prohibitive to deal with it. So again, the UVI system is very simple. You can scale it down or you can scale it up.
Is this something we can just purchase?
Put it this way. I would never tell you to just purchase something. And the reason why is because there's a lot of technical information behind this. And you can buy all the components and build them yourself. And if you go that route, you're going to know every square inch of your system.
You're going to understand it. That's a really
You're
good
going to
point,
understand it. And that is critical because, some of these 2-pump systems, if one pump fails, you're going to overflow or you're going to flood or something's going to die. So there's a lot of these intricacies that are really, really important to look into if you're going to actually do this. And another piece that people don't realize is that the smaller systems are a nightmare to balance. The problem is and this, you have to understand this. If you're going to grow aquaponically, first of all, you have to be a fish expert. And in being a fish expert, you got to know water chemistry, which is a world of hurt in its own. Then on top of that, now you got to be a plant botanist or a
you got to be a gardening expert. Yeah, that's a good point.
Right. So you're really cutting edge between two technologies that have never really merged before until the word aquaponics became, a mainstream word. So it's not something to jump into lightly. I mean, if you want to jump into it lightly, get a 10-gallon fish tank, enjoy the fish, take the filter every week, clean it out, scrub it into a little bucket of water, scrub it out real good, put it back in there, take that water and either dump it on your plants or bubble it. Kind of like what I do. And by bubbling it, you would grow out the good biology that you're looking for.
And
then now you're aquaponics. And we call this an uncoupled system. So by uncoupled or decoupled, you have a fish and you have your plants, but they're not connected. So you're not dealing with the consequences of water chemistry getting out of whack and killing your plants or killing your fish.
Okay, that's a great point. So basically, anything where you're using fish to grow plants is considered aquaponics, and a kind of separated system like that, the uncoupled versus coupled, has to do with the connection. Because some of these systems, the fish are right in there with the roots, right? But you're saying you can get those benefits by growing out the beneficial biology from the aquatic input.
Absolutely. And I would never recommend having fish in direct contact with
Oh, really? Is that not? Okay. Yeah. I didn't know that's not kosher.
There's a betta fish with the little plant hanging in it. I'm sure you've seen it. It's like a vase where you have a water plant in there and there's a little betta fish swimming around. That's fine. That's not an issue. But the problem is if the fish get a little hungry and they start nipping at your roots, now you're going to get pathogens into your plants. And that's not a good thing.
So they're usually, and that's what I've seen too, when I see setups online and stuff, there's usually separated tanks. And now I know why. That makes perfect sense.
Yeah. And again, I've played with some of this stuff and it always goes back to keep it simple, stupid, keep them separated to the best of your ability, whether it's decoupled or coupled. So again, if you're going to get really serious about this, go take a course with Charlie. Understand what you're getting yourself into before you dive in. And then if you're going to go big or go home or decouple, one of those things.
I love that.
Otherwise you're going to get into a world of hurt. And that's another thing that, in the industry, unfortunately, there's what's called aqua shysters. Guys that have a little bit of knowledge but are dangerous and will sell you anything that you want because they're salespeople. And so, that was a joke back 20 or not even 20, 12 years ago that, be careful of the aqua shysters because they're all out there.
Oh my
God. I could name names on some of these, and they're big companies making a lot of money selling systems, and the systems suck. And, most of them end up just being mothballed over a period of time.
Right. Well,
sorry to be so negative.
No, we're looking for that extra boost, right? And aquaponics, I think if you do it right, really does provide that extra boost. And what I mean is, I think there's a lot of focus on terrestrial inputs, like in traditional farming and natural farming, you know what I mean? Like there's really no thought to the aquatic side of our planetary ecosystem. So when you incorporate this, I've heard that there are, huge benefits to your plants. And for anyone who's an avid gardener, it's like you're looking for that boost. So of course people would buy into that, but don't you feel that we focus more on like the terrestrial side? But if you look at the planet and, look at how the ecosystem actually works, that aquatic side of the ecosystem is so crucially important.
Bottom line is, if you look at humanity and how we evolved and populated the planet, we always colonized where the rivers met the ocean. And there was a reason why. You had all that fresh water and you had this incredible abundance of plants, fish, mollusks, animals, everything congregated there. So all you had to do was slap up a shelter and go, okay, what do you want to eat tonight?
Totally.
You just walk out, grab a fish out of the river. I mean, they were stacked up there so hard, and there was fruits everywhere. The deer were there. Everything was there because of the fertility of that area. And across the globe, everywhere you look, there's a major city. More often than not, it's where the ocean meets the river, or a river meets a giant lake, like the Great Lakes.
That's exactly right. So, we were talking off air. You described it like a giant compost tea machine.
Yeah. The river's the compost tea machine, and where the river meets the ocean, that's the uterus, man. That's where all the life comes from.
Wow.
Because the fish come in out of the ocean, they thrash and trash and rip up everything, poop everywhere, lay eggs and split, right?
Right.
So they just fertilize the hell out of the whole area. And the animals come in and they tromp around, trash and eat and then drag up all the diatoms and all of the nitrogen fixers and phosphate solubilizing bacteria and all those other critical aquatic biology all around the shores. And if you ever flown in a plane, everywhere there's a river, there's a tremendous thicket of vegetation on both sides of the bank. Great articles that I've read in the past about how salmon fertilize all of the rivers, the banks of the rivers and the big trees up in Canada and Alaska and so forth, because there's this critical balance of nutrient cycling that occurs right at the edge of those, we call them riparian soil systems. Riparian should be broken up into many, but it's basically lumped to say, it's say up to 2 feet of water up to, 100 feet from the edge of the actual water. Would be considered a riparian system. And it's very unique to all soil systems on the planet because you have that aquatic eco touching the terrestrial eco. And it's a very special place. And generally speaking, it's where the most diversity, whether it's insect, animal, mammal, or plant, on the planets.
Is that why it's so effective? I mean, I hear when people switch to aquaponic growing, when they introduce aquatic inputs, it really makes their plants more vigorous. It increases growth rates. It does all these incredible things. Why is that? Is it something about the diversity of nutrients or the diversity of microbes, a blend of all those things? What?
I would say it's probably the diversity of the microbes over everything. So one of the organisms that's really powerful that lives in an aquatic ecosystem is a phosphate solubilizing bacteria. Now, organic phosphate, is a very difficult compound to break up and make plant available. And that's why we have such problems with it washing into rivers and then creating dead zones in lakes and oceans. Because as soon as that phosphate gets into the aquatic ecosystem, the phosphate solubilizing bacteria hit it, open it up, release it, and then whatever's nearby, algae or plant or whatever, boom, instant fertilizer.
Right.
So that's just one of many. Now, we all know how important nitrogen is for plants. That's why we have NPK. Nitrogen is the first and most powerful of the macronutrients. In reality, in a aquatic ecosystem, you have a number of what's called nitrobacter, or nitrogen fixing biology, bacteria specifically.
Right.
So all of a sudden now, all of this organic N that's tied up in perhaps, compost or plant matter, that N is bound to that carbon. So it's really hard to get apart. You put one of these nitrifying bacteria on it, bam, you just release that nitrogen, plant available. Out of something that would never have been able to release, no matter what you did to it. Without that nitrogen nitrifying bacteria, it's not available.
Wow.
So
incredible.
Again, you start spraying that 10-gallon tank that you do water change once a week and you clean the sponge. All that water's got those good guys in there. And that sponge has got even better ones. They're called protozoa, which are the next level up organisms. So you're talking amoebas and flagellates. Now this gets a little crazy, so buckle up. But it has been recently established that protozoa, specifically flagellates, are now in the algae kingdom, which again, they're moving kingdoms around left and right in the science world. And it's because we were so naive when we started and just decided, oh, well, this is a kingdom. We didn't really know what we know now with all of the technology and electron microscopes. We could start to clump together different organisms in a better or neater package. Some that never fit were like diatoms. Well, now diatoms got thrown in with algae. Flagellates got thrown in with algae. So there is some how do I say this, sticky language here.
Yeah, the semantics, the taxonomy. Always
right.
present.
So I'm sure there's going to be some trolls going, you don't know what you're talking about. Well, unfortunately, I hang out down at Santa Fe Community College. This is the way they talk. And so I'm going to stick with those guys until someone comes up with something better. But now we call them terrestrial algae. See, most people would think, well, there's algae has to grow in water. Well, in reality, based on these new kingdoms, we have what's called terrestrial algae. So algae that grows in the soil. And it's there. I mean, you can see the chloroplast in it when you microscope it. And again, like a lot of the diatoms will have chloroplast as well as regular what we call more of a terrestrial shell. I mean, they're actually made of glass on the outside.
Wow.
Silica, pure silica. So some of these organisms are like right in that riparian system where they're on the land, but they're also in the water.
Mm-hmm.
And so we don't know. We assume that how they're getting to the land is the ducks, the animals climbing in and out of the shore, humans, wind, waves,
dragging that aquatic life onto the shore.
Yeah. So and that's how and why those areas are so fertile. So circling all the way back, these critical aquatic organisms are amazing for plants, plant defenses, bricks, minerals, nutrients, vitamins, metabolites, all of those things that you're looking to get out of your plant. By adding in this aquatic biology, you're blowing those things off the chart. And you're never going to get that level of what we call plant potential without the introduction of those aquatic organisms to the soil system.
Mm-hmm. And that's exactly what I'm hearing too. I talked to a bunch of people, like yourself, a lot of natural farmers, Chris Trump, these people who I respect so much. And it's like diversity. The word diversity comes up so much. And if you look at our current farming system and how much it's failed, one of the things that's really, really lacking is diversity. So that seems to be, really the key is not just natural inputs, because you're going to fail with one or two natural inputs. You need a whole host of natural inputs, because that's how things have worked for the past, 1,000, million, billion years, whatever it is.
Yes, we'd call them the suite. You want the full suite of organisms to the best of your ability, and that's where aquaponics has a real leg up over conventional farming. Mm-hmm. And again, there's many ways to do this. You can just basically build a pond in your backyard and stock it with sunfish and bass and frogs, and throw an aeration system in the middle so that you maintain a high level of dissolved oxygen. And that'll do two things. First of all, it'll increase the diversity of the pond. It will increase the dissolved oxygen of the pond, therefore providing you a higher density biomass of these organisms to pull from. And then you just use that water to water your row crops or your backyard garden.
That's so incredible.
Yeah, you can literally have like one of those little kiddie pools, just sink it in the ground, throw some koi in there, feed the heck out of them, and have a little filtration system so it doesn't get all gummy and algae, and then just take those nutrients and use them on your garden. So this can be done in a tiny scale all the way up to a giant pond.
Can this completely replace like a nutrient schedule? I know what you're doing is a little more complicated. You're doing some, I don't want to say fermenting. I know you don't like the word fermenting, but you're doing some stabilization of fish
aerobic
poop.
Stabilization.
Yeah, of fish poop. And my understanding is if you do that, and then I don't know if you also use some of your pond water, you hardly use any other inputs. You don't use any other fertilizers, right?
No. But I will tell you this. I love Chris Trump. I just have the deepest amount of respect for him. He's not only a friend.
Yeah, he does the KNF and all. Yeah.
Yeah, he's a fellow geek. We can go down these rabbit holes.
Yeah, I feel like you two aren't at odds. It's just two different paths. I feel like what he's doing is still philosophically in line with what you're doing. You're just doing it with fish, and he's doing it with like weeds and kind of woodsy stuff.
And we've collaborated on projects together, and I'm sure we're going to collaborate on a bunch more in the future.
That's cool.
Because he knows he's missing the aquatic piece, and I know I'm missing the ferments and all of these added nutrients. Because if we want to push these plants to have the most potential and the largest harvests and the most nutrient-rich and dense fruits and vegetables, then we need to be using all of these things. Again, diversity.
Yeah.
So it's we have a lot of fun together, he and I, and I still think that, yeah, you can grow plants with my stuff or you can grow plants with his stuff. But if you grow plants with both of our stuff, bam, you're on another level. And, we've definitely seen, really great results by working, both sides of this angle. Because there are some pieces that get a little bit complicated. Like in nature, things dry out or get oversaturated. There is no controlled environment, and now more so than ever with extreme weather, anything can go. So can I establish a long-term inoculation of the soil with aquatic organisms? I don't have the answers for that. I don't. I could tend to see that if we went through a drought and the soil really did dry out, I know for a fact that most of these organisms are going to do what's called cysting. So they basically create a little wax shell around themselves in a perfect sphere, and they can live in there for thousands, even hundreds of thousands of years.
Wow.
But others can't. And we don't have the science. I mean, we haven't identified like a 1% of all of the overall biology that's existing. Jeez. Whether it's fungi, bacteria, protozoa, nematodes. I mean, we've just scratched the surface on this stuff. So, and it's gonna be 20, 30 years of supercomputers just plowing through all of these different organisms to really be able to say, okay, this bacteria has to have that bacteria, or this bacteria has to live before this one can evolve. There's just communities upon communities that have to work together. So in my mind, by taking an aquatic or a riparian style biology and just plowing into a pure terrestrial system, unless that moisture is maintained, I would tend to believe that in a extreme situation, you're going to lose some of that diversity. So you're going to have to bring it back. So I think that, it just to get people's mind wrapped around this, if you're going to take this approach of, trying to inoculate the soil with these creatures or organisms, that you're going to have to do it periodically.
Right. It's not just going to self-sustain.
Yeah, it's not a one and done. I mean, originally, I had great results in landscaping systems that I would actually engineer the soil for, install the soil, work with the irrigation company, get everybody on the same sheet of music, and I would inoculate it with my products. I'd come back 2 years later, everything was great. The systems were thriving. When I microscoped it, my amoebas were there, my flagellates were there, my saprophytic fungi was there. So I know I did inoculate it, but are the phosphate solubilizing bacteria still there? I don't know. Are the nitrogen fixers still there? I don't know.
Well, we're going to learn more and more. Like you said, it's a developing science,
Yes, it's very much in its infancies at this point.
Yeah.
But again, we're learning at a rate that's so fast now compared to what it was 5 years ago, 10 years ago, 50 years ago, that there's going to be, a lot more information coming out from many different angles. And let's face it, the more people realize how bad we've really been with using all these synthetics and, what we're going to have to do to rebuild these systems, there's more and more demand for this information, and there's more and more products that are going to come out and be available. The one thing I would recommend people think about is the difference between in vivo and in vitro. In vitro is something grown in a lab. So you take these bacteria, you grow them out in this perfect environment with a perfect temperature, perfect pH, perfect foods, and then you take them out of this perfect environment and you throw them into a hostile world of the existing soil system. They're not going to probably last very long. So, a lot of the manufactured biological products, I highly recommend you stay away from them because you can make your own at home. One of the big things that Chris Trump talks about is IMO, indigenous microorganisms, and how to get them. IMO 1 is all about saprophytic fungi collection. IMO 4 is all about harvesting nematodes, protozoa, amoebas, and some of the microarthropods, some of the most critical organisms for soil health. And so, again, there's no reason you can't do the same thing. I would recommend that if you're serious about this, that you do take one of Chris Trump's classes so that you really understand how to do it, because there's a lot of nuances to this. It's not just, one and done. Oh, I understand how to do this.
Right.
There, you really have to be a good study.
Yeah, there's a crazy amount of knowledge and study that goes into this. And I think that maybe you can give us a little bit of insight on this before we go, Leighton. I think that it really, like, the layperson is worried about this type of farming because a lot of it goes against our traditional farming, right? Like, for instance, people talk about bad bacteria and how you should worry about bad bacteria. Just a really simple example would be when you're replanting, remove the roots because you don't want any rotting bacteria in there in your sterile soil, because that could cause a problem for your next run. And then I'm talking to these natural farmers who go, no, your soil, you're doing living soil and it's loaded with microbes. That's all good plant food. So can you maybe talk about like what's required and the differences in good bacteria, good biology, bad biology?
Yeah. All right. So think of it this way, right? Briefly, if you kill everything, the first thing that usually comes back are the bad guys. The same thing is true with synthetic farming, which has been the whole farming industry since, the 50s and 40s and 30s. I mean, fertilizer, I think, was invented in 1890 something. But anyway, so that whole system was always focused on pesticides. Because what happened is they'd use these synthetic fertilizers, which would sterilize the soil. It make the plant weak, so the plant would not have a good immune system. It would not be excreting smells that would prevent pests from coming in. So it was literally one sick, unhealthy plant, one sick, unhealthy soil system, and tons of pests. So you're using herbicides because you're not in the right plant succession. So you got to knock off these weeds. Well, they're not weeds. They're just early succession plants because you don't have any fungi because you killed all that with your fertilizer. Oh, next you got fungicides. Oh, damn, we got fungus problems. Well, yeah, because your plant is so weak that, and again, there's no good guys left. So the pathogens set in.
Wow.
So you're beating the soil system down so only the bad guys can survive. So that's why we have these bad biologies. Well, in reality, if you have a balanced soil system, you want some of those bad guys because they're food for the good guys. And the whole system works because it's balanced. And that's why KNF works so well. It's because the whole goal is to get the system up and running to a balance and then let it shake itself out. Like, all right, this particular plant doesn't grow well in the system because of the soil or the nutrient or the moisture or the appellation, the wind, whatever. Don't grow that here. Let's find something that does grow good here. So there is some common sense approaches to this. But once you get a balanced soil system, if you're using common sense, you're only growing plants that are right for your appellation. Your appellation is your area. How much sun, how much wind, how much water, how cold does it get? How warm does it get? Taking all those things into consideration. Like where I am right now is Oxnard, California. It's the strawberry capital. Why? Because guess what? It's the perfect environment for them.
Right.
And the people here have learned, hey, why? I'm not going to screw around with corn. Let's grow strawberries. They do well. They're a cash crop. And why fight the system? So a lot of that has to apply to the individuals wherever they are in the country or outside the country for that matter. Just pay attention to your appellation. What is your weather like? What grows good there? And then focus on those things, and then start to apply these KNF, Korean natural farming, or soil biology, aquatic biology, aquaponics or aquaculture, whatever you want to call it. And you can utilize local systems because I guarantee you there's probably more aquaculture around you than you realize. And aquaculture is growing fish on land, for lack of better words. Now, it also happens in seas and lakes. You have oysters or salmon, you name it. But you're going to see more and more land-based because it's just so difficult to control nature in these aquaculture systems. I mean,
but that's what you're really trying to do is reincorporate nature is what you're saying. The problem is we completely stepped in and halted the cycle of nature and we need to reincorporate that.
Right. So the fish came in and then they trashed and nutrified the hell out of the place and then they left. right?
Right.
But now we just put them in cages and we just nutrify, and we wipe out the whole bay. And that's what's been going on all over the world. And so that's a bad way to do aquaculture. And hopefully humans continue to learn not to do that anymore, and really start to put them in tanks and ponds on the shore, so that they're not destroying nature, and better yet, you can control them at a level where you're not dealing with other like storms, surges, predators coming in, and creating even more havoc. So, but locally, I mean, there's trout farms, there's bass farms, there's perch farms all over the country. So just look what's local and then go to them and say, hey, can I get some of your fish frass? Of course, you want to come home and stabilize it. You can use it in anaerobic. You can. I mean, it's better aerobically stabilized because you're going to grow out all the ones you really want. But even the bad ones, if you dump them into a soil system, everything's going to fight its way out. And generally speaking, if you have aerobic soil, it's going to go back to aerobic eventually.
Interesting.
But
just really
you're
quick,
going to get all that.
What does that process look like? Do you just bubble it? Do you oxygenate it?
Yeah. It's a little bit more complicated because it depends on what level of anaerobic you have. In my early work, I would go to these fish farms that were horribly mismanaged, poorly engineered, and poor morale. And so
harder to revive than other ones.
Yes. It would take sometimes I had stuff that I would bubble for 2 weeks and still couldn't get to be completely aerobic. And other times when I worked with some of these fish farmers and I explained to them what I was doing, and they got it, and they started to clean up their practices, like scrubbing out the biological filters, cleaning out the all the pipes more regularly. They could see the fish health would get way better. And a lot of these guys would sell in live Chinese markets. So the guys would come in and they'd line up and look at the fish tank and say, oh, that red one or that white one or the black and white striped one, that's the one I want. The guy goes in there, catches that fish, fillets it up, sends him on his way. So if the fish looked really good, he could get more money for him. And if the fish didn't look good and that fins were, kind of not all fully developed and just didn't look super healthy, he didn't get the same amount of money. So by cleaning up his system, his fish were healthier, and it was way easy for me to stabilize it. Some of these I could stabilize on the way home in a couple hours. Some of them in a couple days.
Man, that's interesting.
But some of them, it was just so hard. I gave up after 2 weeks and just said, screw it, I'll use it anaerobically.
What an interesting intersection of the aquatic life and learning to care for fish and our oceans, and then also the natural farming side and the nutrient side for the plants and the soil science side. I want to talk to you about dual root zones. I want to talk to you about, uncoupled systems, coupled systems. We're just getting started, man, but we got to wrap it. We got to wrap it here. We've already done the whole show. So listen, we'll have you back on another time, Leighton. Keep doing God's work out there. If people are looking for an aquaponic consultation or maybe some sort of aquatic input consultation, where can they find you?
Probably the easiest way to start is Kingdom Aquaponics LLC at IG. That's really
Perfect.
easy. Spelling my name is Leighton, and that you would be Leighton at Kingdom Aquaponics LLC.com. And don't forget the S on the end of aquaponic. And you can go to my website again at kingdomaquaponicsllc.com. But that's probably Instagram's the easiest way to find me real quick, and then we can exchange information and go on with emails or phone calls or whatever's next.
Man, I'm so interested in this subject. Keep doing what you're doing. Keep us up to date. And thank you for taking the time to come on the show.
Yeah, absolutely. We'll do it again soon.
Sounds great, man. Everyone listening, thank you so much for tuning in. I hope you enjoyed today's show. This is Jordan River and Leighton Morrison from Kingdom Aquaponics signing off, saying have an extraordinary day. We'll see you next time on the Coffee, Health, and Science Podcast.